The 15th question says that show that the altitude of the right circular cone of maximum volume that can be inscribed in a sphere of radius r is this. Okay, so we are talking about a sphere, and in a sphere we are talking about right circular cone having maximum volume. Okay, so this is the right circular cone, let us say, in the sphere. This is what you have. This is the center of this is the radius of the right circular cone, this is the height, and this here is the center of the sphere. This is capital R, let us say, this is again capital R, and if this is the height of the right circular cone, I can easily get this distance over here. This is 90 degree. So I can easily get a relation between this h minus capital R and small r. This triangle is a right angle triangle, right? Show that the altitude of the right circular cone of maximum volume of cone has to be maximized, okay? That can be inscribed in a sphere of radius r. Okay, the radius of the sphere is given as small r. That's pretty interesting. We have taken the radius to be capital R. Let's change that. Let's change those things. Okay, and what do we have? This is small r, and let's take this radius as x for that matter, right? Okay, and to prove, what are we supposed to prove? That altitude of the right circular cone h is equal to 4r by 3. This is what the person says, right? Volume is maximum. Okay, we have solved a similar question in the exercises before this, and we can handle this one as well, right? So what do we have? This is h, this is r, so this becomes h minus r in this right angle triangle. H minus r, and I can get a relation easily between h minus r and this. What about the volume of the cone? Volume of the cone is 1 by 3 pi r square. Instead of r, we have x square, and this is h, right? Altitude of the right circular cone of maximum volume that can be inscribed in this is this. Given the radius r of the sphere, I have one relation. What is that? R square is equal to h minus r whole square plus x square, right? And which of these can I eliminate? Can I eliminate x square? Can I eliminate h? I can eliminate x square very easily. This is pi by 3 h times x square is nothing but r square minus h minus r and its square. This is what you have, right? This can further be done as pi by 3 times h r square minus, what is this? Can we simplify this? Yes, we can simplify this before actually multiplying the h inside. Let it remain as it is. This becomes r square minus h square minus r square plus 2hr. This is what you get. R square gets cancelled, and what you're left with is pi by 3 times 2r h square minus h power 3 is what we are remaining with, right? This is what you get. This is the volume, okay? And once the volume has been written in terms of this parameter h, we can differentiate. D by dh of Vh. What is that? Pi by 3 is okay. This is equal to 4rh minus 3h square, okay? And the critical points will be h equals 0 will be the one of the points. H will come out common. Rest will be 4r minus 3h. So h will be equal to 4r by 3. And you can clearly observe that for h equals to 0, the height will be 0. Therefore, volume will be 0. This will be a minimum condition, and this will be for maximum condition. That's what you can see very easily, right? Although you can talk about the double derivative as well, that the double derivative will become 4r minus 6h, and this will be equal to negative for this one. Sorry, this will be negative, yeah. So there will be maximum at this particular point. So volume maximum occurs for Vmax for h equals 4r by 3, and this is what we wanted to prove, right or not? Yes, this is what we wanted to prove. That's a complete proof of this particular question, question number 15th over here.